Okay, guys, with this lesson, we're going to take a look at a system of linear inequalities. So since we're referring to inequalities instead of equations, we're going to have many solution points. So again, with a system of linear inequalities, we will have two or more linear inequalities. We're just going to focus on two of them. And we're going to be graphing these on the same coordinate plane. And we're going to be doing some shading since we're talking about inequalities. And where the shading of both inequalities overlap, that will be our solution set, which will be a region. So we'll have infinite amount of solutions. So let's take a look at this example. This is what a system will look like when graphed. Notice we have two different lines. We have this red dotted line, so that means it was open, and it was shaded above the boundary line. Then we have the blue boundary line that is solid, so this means it was a closed inequality, and this graph was shaded below the blue boundary line. Where we see the crisscrossing of the blue and the red, this region here, let's see if we can use a highlighter. So this region here, so the blue line, we can include those points up to the dotted line, not including those, in all of this space, and really our coordinate continues forever. Whoopsie. It continues forever. Okay, we just see a portion of it. So again, it would continue forever and ever in both of these directions. So out and up and down. So all of these ordered pairs here, so for example, this ordered pair here, which is 5, 3, would be a solution to both of these inequalities. So graphically, your solution set is where your shading overlaps. Algebraically, your solution set is all those ordered pairs that when plugged in for y and x in both equations, we get true statements. So let's go ahead and take a look and graph these two inequalities. They must be in the form of y is, I'm just going to say equals, but we know we're going to have an inequality, mx plus b. So we need those in slope-intercept form, just like when we graph a system of linear equations. So we're going to just add 2x to both sides. And we get 3y is greater or equal to 2x minus 3. Divide by a positive 3. If it were negative, yes, I would have to reverse my inequality. And this equation is y is greater or equal to 2 over 3x minus 1. I'm going to go ahead and graph this. I'm going to start at 0, negative 1. I am going to use my slope, rise of 2 and run of 3. So up 1, 2 and right 1, 2, 3. Up 1, 2 and rise. Up 1, 2 and run 3. 1, 2, 3. I'm going to reverse the slope. So I'm going down 1, 2 and left 3. Now before I just connect my points, I need to notice what kind of boundary line I'm going to have. Because this is included, it's solid, I will have a solid line. Now, we need to know if we need to shave above, this is going upward, above the boundary line, or below. So you look at your y, and if it is greater than, so if you have y is greater, the mouth is open, you're going to shade above the line. So I'm going to shade above. We could use a highlighter probably and shade in a little bit better. I might try that on the next one. So I'm shading above all these ordered pairs and the points on the line make this first equation true, or inequality. Now, our second one is already in slope-intercept form. I'm going to use a different color. I'm going to start at 0, 4. I'm going to go down 3, 1, 2, 3, and to the right 1, 2. Down 1, 2, 3, and to the right 1, 2. I could also go up 1, 2, 3 and left 1, 2. And y is less than, it is not included. So the way we represent a line, some ordered pairs that are not included, we use a dashed boundary line. All of these ordered pairs are not included as part of my solution set. Then we have y is less. So when we have y is less, we shade below. So I'm going to shade below. So I'm going to go in a downward motion. I'm going to shade all of this region below the red line. So using different colors, graphing these is very helpful. Now, the region in which it overlaps, let's get this, we'll do green. The region where we have the overlapping of the red and the black, this area is your solution. So I'm going to put an S for solution. That's what the instructions say. So all of these ordered pairs, including the ones on this line up to the dotted line, but not included in over all of this area, these ordered pairs would make both equation 1 and equation 2 true. Okay, these two equations we need to put in slope-intercept form. So let's solve here. We need a pen, and I don't know if, let's just do the white will show up. So I'm going to subtract 2x, subtract 2x. I have y is less than negative 2 over x minus 3. So let's graph this one. We're going to start at 0, negative 3. We're going to go down 1, 2, and to the right 1. Down 1, 2, and to the right 1. Up 2 and left 1. Our solutions do not include, I do not have the equal part, so I'm going to have a open or a dashed boundary line. It says y is less, so that means below. Now our second equation, let's solve for it. For y, I'm going to subtract x from both sides. I have negative 2 times y is less than or equal to negative 1x minus 4. Here, guys, remember, I'm dividing by a negative, so you always have to reverse your inequality to the opposite. So now it becomes y is greater or equal to, we have a negative over a negative, so that's going to be positive 1/2 x plus 2. So let's graph this one. So we're going to start at 0, 2. We're going to go up 1 and right 2, up 1 and right 2, or down 1 and left 2. We have the equal sign here. Y is equal, so all of these points are included. So I'm going to make a solid boundary line. It says y is greater, so we're going to shade above. And our overlapping solution sets are in this region here, from here up through here. This is all my solutions. Graphically, my solution set is where the graphing overlaps, where the shading overlaps. Algebraically, my solution set are all those ordered pairs that make both equation 1 and equation 2 true. We have y is greater or equal to 1/2 x minus 3. Let's go ahead and graph this. We're going to start at 0, 3. I should say 0, negative 3. Our slope is up 1 and right 2, up 1 and right 2, down 1, left 2. It is included, all the points on the boundary line are included, so I'm going to shade those in by a solid line. We are going to shade above because y is greater, so greater indicates above. Okay, now let's solve for this one here. We're going to add x and add x. We're going to have 2y is less than or equal to x minus 2. Let's divide by 2. And this new equation is y is less than or equal to 1/2 x minus 1. Let's graph this. We are going to start at -1. We are going to go up 1 and right 2, up 1 and right 2. Now we can see these have the same slope, but this is different than an equation, and we can't immediately say there's no solutions. If this was just an equation, we'd say no solutions because the lines are parallel. Whoopsie doodle. Oh, I'm glad I'm doing a solid line. I didn't stop to check, but we do have a solid line because it is included right here. This is what makes it a solid line. Now we're going to shade below. You see how we do have some overlapping, even though I didn't do enough of the green shading. Let's go back and do that. So this green we were shading above. So we actually do have a small region of ordered pairs that make both equations true. So our solution set is this narrow region here. Come on, Miss Thomas. Okay, right here. Oh, it didn't change colors, but that's okay. All of these points and the ones on the lines, okay, because we shaded above, the green was shaded above, the red was shaded below. So these are your solutions. So you do have solutions sometimes when you have parallel lines with inequalities. If our solution was the opposite, if the red was shaded above and the green was shaded below, they would not have intersecting regions of shade. Okay, let's graph these. Here we have the horizontal line, y is greater or equal to -2. So all of these points create that horizontal line because our ordered pairs all have a y value of -2. It is going to be solid, but let's get a color that might show up better. So this is solid. Here's the boundary line. It says y is greater, so I'm going to shade above. Why don't we try out the highlighter? So these are all the solutions for my first equation. Okay, that's nice. I like that. And then for our next equation, x is less. So this is that vertical line. So this is not a function. So I have x going through the 3, and those points are not included. So I'm going to put a dash line. And it says x is less. So we're going to shade to the left. So all of the, oopsie, red. So all of these points, oh, look how that does that. That's kind of cool. And all of these are all the solution points for the red. So you can see in this area here, this overlapping is your solution set, S for solution set. Nice. Okay, let's try one more of these. Y is greater than 1, so we're going to have the horizontal. It's going to the 1. These ordered pairs are not included because we do not have the equal sign. We're going to shade above because it says y is greater, so that means above. Oh, that is not the right color. Sorry about that. Let's go. Here we go. All of these ordered pairs make this inequality true. Pen, and let's do purple. Y is greater or equal to 2x plus 3. This is in slope-intercept form. I'm going to start at 0, 3. We're going to go up 1, 2, and right 1, up 1, 2, and right 1, down 1, 2, and left 1. It is solid because we have the equal sign. This is what makes it solid. And let's shade these. Put it on purple. Y is greater, so I'm going to shade above. So that's all these points here. And then my solution set is going to be right here. I guess that may not have been the best choice. Let's do yellow. So my solution set is where the purple and red, whoopsie, overlap. So this region here. This is my solution set. Okie doke, let's do another one. Hopefully by now you understand, but it doesn't hurt to do more. These are both in slope-intercept form. So we're going to start at 0, -2. Our slope is up 1, right 1, up 1, right 1, or down and left. It is open because we don't have the equal. It is shaded above. Very nice. Okay, and let's go to our second one. Again, we're in luck because it's solved for us in slope-intercept form. Start at 0, 3. We're going to go down 1, 2, 3, 4, 5, 6, and write 1. 1, 2, 3, 4, 5, 6. Is that 1, 2, 3, 4, 5, 6, and write 1. Or we could go up 1, 2, 3, 4, 5, 6, and left 1. It too is open because we don't have the equal sign. And let's get some shading here. And we will go with this blue. So our purple line we're going to shade with blue, and it's less than, so it's below. Oh, it's green. Whoopsie. So we can see our overlapping of the yellow and green, and this would be our solution set. Our solution set is here. All of these ordered pairs. Those ordered pairs would make both this equation and this equation true. Let's solve for y. Subtract 6x minus 6x. Bring down my negative y. So be careful here. We're going to be dividing by -1, which is going to reverse our inequality. So I get y is greater than positive 6x minus 3. Let's start out at 0, -3, and up 1, 2, 3, 4, 5, 6. This is going to be open, and we are going to shade above. No, I do like the highlighter. All of these ordered pairs, and as the coordinate plane continues forever, are my solutions for the first equation. Now let's take a look at our second equation. We're going to subtract x minus x. That's not showing up too well, and we want to make sure we can read this. We have negative y is less than or equal to negative x minus 2. We are going to divide by a -1 again, so we have to reverse, and we have y is greater or equal to positive 1x plus 2. So we're going to start at positive 0, 2. We're going up 1, right 1, up 1, right 1, or down and left. This is solid because we have the equal to, and we're going to shade above because we had to reverse our inequality. Let's see what the black highlighter looks like. So we're going to shade all of this region. And then we can see that our solution set is this, and then up to here, and all this region is where it's overlapping. That's my solution set. Okay, let's solve. We're going to subtract x. This is an easy y is greater or equal to negative x plus 2. Starting at 0, positive 2. We're going to go down 1, right 1, or up 1 and left 1. It is solid. We're going to this is what happens when you get in a hurry. You make these mistakes. Let's not do that. Let's erase this. And let's use the highlighter. And we're doing black. Y is greater, Ms. Thomas. So we're going to shade above. Okay, let's do our next one. And I think the red shows up nicely. Subtract x. Y is less than or equal to negative x, negative 1x minus 1. And that did not change to red like I thought it was going to. So this is the equation for the red. Okay, so let's plot this at 0, -1. We're going to go down 1, right 1, down 1, right 1, or up and left. It is going to be solid. And we are going to shade below. So let's do the highlighter, make sure it's red. So we're going to shade below. So this one has no solutions. There's no region where our overlapping will happen. There will be no overlapping. So no solution. I hope this helps.